Alright, let's go ahead and have a peek here at infinite limits. And in order to do that, first we have to start a little discussion about vertical asymptotes, because they're very tied. They're tied very closely to one another. So let's go ahead and just take a look at a function here. Let's take a look at a function f of x equals 1 over x. Start with a little example here. So a function has a vertical asymptote when you put a value in for x and you get a non-zero number on top and 0 on the bottom. So for example here, this is kind of simple. If I plug 0 in for x, I end up getting 1 over 0. Okay? So again, the top is non-zero, it's 1, and the bottom is 0. Okay? So therefore we know that there's a vertical asymptote, just abbreviated VA, at x equals 0 on this function. Now, what a vertical asymptote looks like, in this case, this graph looks like this. At a vertical asymptote, okay, a graph goes to infinity or negative infinity. So you can see here at x equals 0, if I look from the right-hand side here, as the graph is approaching 0, the y value is getting larger and larger and larger and larger. Okay? Which makes sense, because if I just think about plugging in values into x as x gets closer to 0, which we're using the idea of limits here when we think about this. For instance, as x is, say, 0.1, well, if I do 1 divided by 0.1, that's 10. As the x value gets even closer, say, for instance, at 0.01, it's, the x value is 100. As I get even closer, the x value, say, is at 0.001. Now the y value of the function is at 1,000. So the idea is the closer I get to 0, the larger the function gets, and that's the idea with the vertical asymptote. Okay? And the same thing is true on the left-hand side. It's just that instead of the values getting larger, they continue to get smaller. So it would be like the same thing would be like -10, -100, -1,000. So it's going down like that. So again, the idea is if you look at a function and you want to find where does it have a vertical asymptote, you want to look at the places when you plug a number in, the top is non-zero and the bottom is 0. Okay? Now, let me just give you another quick example of that. Say we had a function h of x is equal to x minus 3 over x squared minus 9, for instance. Okay? Now, you do have to be careful to look here, and again, what we're doing is we're looking for where does this function have a vertical asymptote, okay? And you have to be careful knowing what's going on the top here. So let me just factor the bottom out, make it easier to look at the bottom. X minus 3 times x plus 3. And so I notice the bottom. If I plug 3 or -3 in, the bottom is 0. But I notice on top, if I plug 3 into the top is 0 as well when x is equal to 3. So x equals 3 is not a vertical asymptote. Okay, x equals 3 is not a vertical asymptote because when I plug 3 in, it's 0 over 0. What you would see on this graph at x equals 3 is a hole in the graph. Okay, now at x equals -3, if I plug -3 into the top, I would get -6. And if I plug -3 in the bottom, I would get 0. So at x equals 3, there is a vertical asymptote. X equals -3. X equals -3. There is a vertical asymptote. Okay? So that's one thing that's a little confusing because in this section usually you're talking about continuity and other things. So, you could have a question about this, a function, where is this function not continuous? Well, the answer to that would be at x equals 3 and -3. It's not continuous at either one, but if you're asked where does this have a vertical asymptote, only at x equals -3. Because that's the only time you plug in you get a non-zero value over 0. Okay? All right. Let's see how this then can apply to limits and helps us out with that. So let's just say we have something like the limit as x approaches 1 from the left, let's say, of 1 over x minus 1. Okay? Now with limits, as I've said all along, you always want to plug in. Always plug in first. Okay, it's going to tell you a lot about the problem. So in this case, I take 1 and I plug it in where I see x. I get 1 over 0. Okay, right away I should notice, okay, 1 over 0, that's non-zero on the top, 0 on the bottom. This function has a vertical asymptote at 1. So I know right off the bat that the limit of this basically is either infinity or negative infinity, okay? Because that's what happens at vertical asymptotes. Graphs go to infinity or to negative infinity. Now, because I know that it's infinite, that means that the limit does not exist. So right away from the beginning, I could just say that this, does not exist. That would be acceptable, okay? Because, if I just put infinity, that still just means it doesn't exist because it goes to infinity, okay? So that would be, I think, the easiest way to go about this because you don't have to think anymore about it. Now let's just say you wanted to decide, does this go to infinity or does it go to negative infinity? Well, you could decide that by thinking, okay, well, I'm dealing with as x approaches 1 from the left. So let me just choose a number that's very close to 1 from the left, like say 0.9. If I plug that in, I can just test to see whether that value is going to be positive or negative. So the top's clearly going to be positive. At 0.9 minus 1 is going to be negative 0.1. So I know that this is going to be negative. In that case, I plug in 0.9, I'm going to get negative 10. Okay? And if I plug values in closer, I'd still get negative values. So I know that this is actually, if I wanted to, I could put negative infinity, which again just means the limit doesn't exist since it's going to negative infinity. Okay? Now let's just say, for instance, I had done this. The limit as x approaches 1 of 1 over x minus 1. Okay? So the same problem, but instead of looking from the left, I'm now looking just as x approaches 1. Well, if I'm approaching 1, that means I have to look from the left and from the right. Okay? So when I plug 1 in to start with, I get 1 over 0, which tells me vertical asymptote, it's going to infinity or negative infinity. Okay? So in this case, again, I'd say just right from the start put DNE. But if you're one that just wants to check, you have to check both from the left and from the right. So if you plug in 0.9 from the left, like we just checked, you would get a positive value. Say you plugged in 1.1, you'd get a, if you plugged in 0.9, you'd get a negative value, like we just did. If you plugged in 1.1, you would get a positive value. So from the left side and from the right-hand side, it's going to different values of infinity. So your only option in this case is to put DNE. But again, why do any of that extra work? I would just from the start just put, DNE. That seems to be the most sensible thing to do in that case. Okay?